Now, on exponential expressions that we need to be applying factorization, it's very, very important that you understand your basics of your factorization. Some of us will be wondering, why are we talking about factorization on exponents? What is it that we are actually factorizing? What is it? Okay. Considering our exponential expressions that we talked about, the moment we talk about an expression, it means factorization can take place. All right. We had the previous case where we had questions that were of this nature. 2 to the exponent of x multiplied to 2 to the exponent of 3x, everything over 2 to the exponent of maybe 5x or 3x, whatever that you be given there. It was a multiplication, a division that was occurring there. So on this scenario, we are not having multiplication division, no. We are having that, yes, but addition and subtraction, they are also included. Remember, if I have x squared plus 2x like this, it reminds us of what? Of factorization, where I can factor out the highest common factor. So it is the same thing with our exponents. 2 to the exponent of x, when being added to 2 times 2 to the exponent of x like this. Yes, here we are multiplying, but what we see is that these two, they are common. 2 to the exponent, as it is the whole of this part and the whole of this part, they are common, they are the same. So what does it mean? I can factor out that common term, 2 to the exponent of x, which is the one that I see here. I also see it here. So if I factor out this out, if I factor out this, I'm going to divide. So this part of 2 to the exponent of x will cancel with this because they are the same. But you do not cancel this side, you cancel on this part. So this will give you a 1 plus this one is the same as this. So if you cancel it, you remain with a 2. So this is a 2 there, okay? You remain with a 2, which we can add now. 1 plus 2, which is what? Which is a 3. So this is 2 to the exponent of x times a 3. So we can just rewrite this as 3 by 2 to the exponent of x like this in simplest form, which we could have just applied that to say that these two are the same. Here there's a 1, here there's a 2. So I can simply add these two. But in most cases, you have conditions whereby now you've got negative exponent, this and that. That's why I want you to know how to factorize so that if you have those conditions, you can simplify as much as you can. All right, so there we are asked, simplify. All right, number 1. 2 to the exponent of x plus 2. All right, let us just write it so that we can just properly work this together, guys, without limitations. Let us just rewrite this. Everything here is over 12 times 2 to the exponent of x like this. Okay, this is what we have. Now, I want you to consider this. You are adding here. So the part that you are just adding, that part alone, this one, whether you are adding or you're subtracting, it tells you that there is a need for you to factorize what is common between these two. But now it's difficult for us to see what is common because here there's something that we are adding, there's something that we are also adding here. But we can properly see that there's a 2 to the exponent of x that can be taken here. There's a 2 to the exponent of x that can be taken from there. But how can we do that so that it is the same as this one? How can we do that? We are back to our laws. Whenever you're given a condition like this, it means you were multiplying 2 to the exponent of x to 2 to the exponent of 2. Remember, if you're multiplying, you're going to add your exponents if these two are the same, the bases. So it means here I was multiplying 2 to the exponent of x to 2 to the exponent of 2. Okay? Plus, here I was also multiplying 2 to the exponent of x by 2 to the exponent of 3. I'm now breaking it down to where it was before. Here, there's nothing that I can do because already I'm having 2 to the exponent of x. So I'm just going to write as it is. So what does it mean? It means here, if we check properly, there is a 2 to the exponent of x, the same as a 2 to the exponent of x here, which is the same as this one. But for now, we do not want to focus on this one in the denominator. We want to focus on these two on top because those two terms or these two are being added together, okay? We are adding these two, this one to this one, added here. So the moment that it's an addition or a subtraction, you can factor out what is common, which is this one. So you can factor 2 to the exponent of x out. What do you remain with? You remain with this part, okay? You have taken this one out. You're going to remain with this 2 to the exponent of 2 plus, if you take this out, what are you going to remain with? You remain with 2 to the exponent of 3. So this will be 2 to the exponent of 3 like this, okay? We close this, everything over, this is 12 times 2 to the exponent of x. So at that stage, there is a greater advantage that is happening here because we can see that it's now a multiplication that is happening. So remember, on a multiplication, these two, they can cancel each other because they're the same. As long one is in the numerator, the one is in the denominator, they can cancel each other. So I'm going to remain with this part of 2 to the exponent of 2 plus 2 to the exponent of 3. Guys, remember 2 to the exponent means 2 times 2, which is what? A 4. 2 to the exponent of 3 means 2 times 2 times 2, which is 2 times 2, that's 4 times 2, which is 8. So here we simply have 4 plus 8, or we can just use our calculator, 2 to the exponent. At that stage, you can just use your calculator to simplify, okay? So, but if you add, you're going to get a 12. So this is what I'm trying to say. You can just take this direct on your calculator, 2 to the exponent of 2, okay, plus 2 to the exponent of a 3 like this. So this gives us a 12. So this is going to be 12 over 12, and that gives us a 1 because they are the same. So this will be a 1 at the end. So as we can see, we can be able to simplify whatever question that we are given by the advantage of factorizing what is common, provided that the terms are being separated by an addition or a subtraction. They can be a subtraction. You simply do one and the same thing. Let us check if we have that scenario of a subtraction. All right, we have a subtraction there on question number 3. All right, let us check this question here, question number 3. So if we check on question number 3, we are given again to simplify. So that is 2 to the exponent of x plus 2 minus 2 to the exponent of x plus 1, everything over 2 to the exponent of x plus 2 to the exponent of x plus 2 like this. Okay, let us see. There is a greater possibility of us writing in terms of 2 because there's 2 here, 2 to the exponent of x, to the exponent of x, to the exponent of x. But how so? Let us separate. Remember what I said, if you are adding or subtracting there, just multiply the 2, okay? 2 to the exponent of x multiplied to 2 to the exponent of 2. If it was 2 to the exponent of x minus 2 like this, you do the same. 2 to the exponent of x multiplied to 2 to the exponent of minus 2. If we add these two, we get what? Negative 2. So just expand that way, taking the sign as it is. But this one is a positive, so just remain as a positive, okay? Minus, you do the same thing here, 2 to the exponent of x multiplied to 2 to the exponent of a 1. So this is going to be affected by the denominator. Also, we have the same condition, but this one, just single term, just gonna write as it is, 2 to the exponent of x plus, we've got a plus there. Then we separate this, we are adding here, so it's gonna be 2 to the exponent of x multiplied to 2 to the exponent of a 2, the one that is remaining. So we have separated each and every part so that we can properly see the 2 to the exponent of x, which is common here on top. We've got 2 to the exponent of x. So you can factor out. Let us start on top first. So you can see that this is common. So you can factor out 2 to the exponent of x in the numerator. What do I remain with? I remain with 2 to the exponent of 2 minus, here I factor this out, I remain with this 2 to the exponent of a 1 like this, okay? Everything is over what? I go to the denominator, I do the same thing. If we check here, we can see that this is all the same, okay? 2 to the exponent of x, we're now in the denominator here. So we're gonna consider that being the same. So what are we going to do? We're gonna factor that out. So here is same like we're gonna remain with a 1. So if we factor out this 2 to the exponent of x that we see here, we are going to remain with a 1. So it's the same to cancel, we've got a 1 plus, we've got a plus here, we factor out this out, we factor out this, we remain with 2 to the exponent of a 2, like that. So this is how we can be able to simplify these typical questions. So as we can see, these two here are the same. This one is the same as what we have here. So what can we do? We can simply cancel it because we've got the same thing. So this and this will cancel. We are just left with the numbers only here, the exponent of x and this and that. It has canceled. So it means here I'm going to simplify. I can even use the calculator, but I can even simplify it directly. Guys, 2 to the exponent of 2, that is 4, minus 2 to the exponent of 1, which is 2, okay, over this one is going to be 2 to the exponent of 2, which is a 4. So it's going to be 1 plus a 4, okay? Then if we simplify this, we subtract 4 minus 2, that's a 2 over 1 plus 4, which is a 5. So this one is going to give us 2 over 5. So like I said, you can even simplify it direct on your calculator to prove that. But as you can see, that was what was important, okay? What is important is that expand whatever that you're given, rewrite it in a way that you properly understand, okay? This separate it in terms of 2 to the exponent of x. Then after that, you can factorize the numerator. You factorize it on its own. You go to the denominator, you factor out 2 to the exponent of x on its own. Then from there, you can cancel these two because they are the same. Remember here, you are multiplying. So this can cancel out. And then this, you can simply do it even on your calculator. Like I said, if on a condition that you're actually stuck, you're under exam condition, just simplify your calculator, put a fraction here, okay? 2 to the exponent of 2 minus 2 to the exponent of 1, which is same as 2, okay? Over 1 plus 2 to the exponent of a 2, which is going to give us 2 over 5. So as you can see, that's what you can do. That's the friend that you have in exam, which is a calculator. That's the only friend that you can trust. Okay, so guys, that's it. Let us check the other part on number 3. All right, then number 4, I think is just direct like what we just did here, but let us check for the sake of revision. Let's see number 4. Okay. So I want you to try as much questions, but I'm just going to do 1 or 2 questions with you, okay? On number 4, we've got same situation there. 5 to the exponent of x plus 4 minus this, so you're going to have the same consideration. 5 to the exponent of x plus 4 minus 5 to the exponent of x plus 3, everything over this 100 by 5 to the exponent of x plus 1. Okay, so if I am to consider this, I can see the same situation occurring here. So what can I do? Let me get rid of that. So I'm going to separate, okay? So let us just write aside here. So I'm multiplying, so I'm going to have 5 to the exponent of x multiplied to 5 to the exponent of f4 minus the same here, 5 to the exponent of x multiplied to 5 to the exponent of a 3. Okay? In the denominator here, I already have a 100, so do not worry about that. It does not have x, so just rewrite as it is. Focus on this one. So you want to separate this one here. So it's going to be 5 to the exponent of x times 5 to the exponent of a 1. So this now gives us the power to factorize because we can see the same thing common in the numerator here. This one, same thing common also here. So we can factor that common term so that we can see what will be the answer there. We factor out 5 to the exponent of x. What are we going to remain with on that term? We will remain with this one. Okay, so you're going to remain with 5 to the exponent of 4 minus, we remove this. What are we going to remain with? We remain with 5 to the exponent of 3. Everything over here, we put 100 times 5 to the exponent of x times a 5 to the exponent of 1, which is one and the same thing there. So here, these ones, they can cancel because the multiplication that we have, so this one and this one are the same. They can cancel 5 to the exponent of x and 5 to the exponent of x. So meaning to say, in actual sense, we were supposed to remain with 5 to the exponent of 4 minus 5 to the exponent of 3 over 100 times a 5, which you can simplify direct, or you can use your calculator in that manner to simplify this stage at once. All right, just because of the sake of time, let us just have this as 5 to the exponent of 4 like this, minus 5 to the exponent of the 3 like this, everything over 100 times a 5. So this is going to give you a 1 at the end. Okay, so this was going to give you a 1. All right, so that is how we can have these questions. If you wanted to simplify stage by stage, remember 5 to the exponent of 4, that's 5 times 5 times 5, 4 times, which is 625, minus 5 to the exponent of 3, which is 125, everything over 100 times 5, which is 500, okay? Then we subtract this 625 minus 125, it gives us 500 over 500, which was going to give us a 1. So that is how we could have simplified. So as you can see, it's a straightforward situation that you just need to revise. Okay, once you see common terms, factor out those common terms that are common, divide wherever is applicable. That is how you can have your questions. So like I said, I want you to try as much questions as possible just to simplify as you are revising so that you can properly and attempt as much questions as you can. All right, sometimes we might have a situation like what we have on number 6. Right, and number 6 is very, very important because we've got a condition of a negative exponent that I want us to talk about before I close this class. Okay, if we consider on number 6, we are given 6, 3 to the exponent of x raised to the exponent of 2. Okay, let me just write it here. 3 to the exponent of x raised to the exponent of 2 minus 9 to the exponent of x minus 1 like this. Everything over 9 to the exponent of x minus 1. Okay. Never be tempted in exam or in your revisions, in your activities that you'll be given at school. Never be tempted here to cancel these two to say this one and this one are the same. No. Yes, they are the same, but we must do it in a proper way. Which is the proper way? Okay. Now we can see that I do not have anything common that I can factor out so far. I do not have anything common that I can factor out. So what I can think of is, how about I write these two numbers, 9 and 9, as a number in simplest form, which is 3. because 3 is the simplest number that we have, which is a prime number. How about we write these two numbers as a 3? It's possible. 9 is same as 3 times 3, which is 3 squared. So if it is the situation that we have here, it means this one is going to be written as 3 to the exponent of 2, like this. But having another exponent that is affecting already there, because we are given already an exponent that was already there, which is x minus 1. So it means whatever that you're going to have here, it is going to be affected by this 2x minus 1. Okay? So it means here we are going to have it as 3 to the x. Here you can multiply before you check to say, because definitely you're going to multiply by 2. So you're going to multiply this x times 2, which is 2x, minus 3 to the exponent of, you multiply now 2 times x, which is 2x, 2 times minus 1, which is minus 2. So this part here and this part here are the same. We just rewrote in base of 3 in simplest form. So it means that it's a repetition again that I'm having, because it's the same thing that I'm seeing here that I had here on top. So I'm going to have the same answer, 3 to the exponent of 2x minus 2, all right? 2x minus 2, like this. Now we can see that the 3 to the exponent of 2x is somehow there, but still it is hidden here because of minus 2, here because of minus 2. So what do? That's where I think of simplifying first, so that I can be able to factorize, rearrange in a way that I can be able to factorize this. All right, so how can I rewrite this? Okay, let us consider this one. Let us consider this one. There's nothing there, so you can just rewrite as it is. Okay, minus on this part, you are subtracting, yes, which is true, which is very, very true. But I want you to consider this. 3 to the exponent of x, when multiplied to 3 to the exponent of negative 3, what's going to happen is that you add, isn't it? You add this, which is going to be 3 to the exponent of x plus minus 3, which is minus 3, which is the same thing as what you're thinking about of division, to say 3 to the exponent of x over 3 to the exponent of 3. That is how it was supposed to be given as, which is true, very, very true. But most of you tend to have mistakes in working with this one. So that's why I advise you to simply have it as it is, to separate this way with a negative that way, okay? So meaning to say here, if we separate this, we are going to have 3 to the exponent of 2x times 3 to the exponent of negative 2. Okay, everything over what? What we have in the denominator here, again, we have to separate in terms of 3 to the exponent of what? 2x. 3 to the exponent of 2x multiplied to what? To 3 to the exponent of negative 2. If you do it that way, guys, you won't have a problem. Okay, let me explain it this way. You're going to use your calculator so that you can properly see. Now that in the numerator here we have the 3 to the exponent of 2x, which is the same as the 3 to the exponent of 2x that we have here. Let us factor it out from the top, from the numerator there. So we are going to factor out 3 to the exponent of 2x. What do I remain with on this part? I remain with a 1. Minus, what about this part? If I factor out this part out, what do I remain with here? If I factor this out, I'm going to remain with this part, which is 3 to the exponent of a negative 2, like this. Okay, but in the denominator here, there's nothing that we can do. We're just going to rewrite as it is, this part. 3 to the exponent of 2x multiplied to 3 to the exponent of negative 2 like that. So what are we going to have at the end? We are going to see that these two are the same. So this one and this one will cancel out. I'm now remaining with the bracket of 1 minus, I can even write it just as it is, 1 minus 3 to the exponent of minus 2 like this over 3 to the exponent of minus 2, because this one, it is cancelled out. So at that stage, you can just use your calculator like I mentioned before to say, if you do not understand at this stage, just plug in your values in the calculator. You are at the last stage where you just need 1 mark to find your answer there. So meaning to say, we can just simplify, put a fraction, 1 minus 3 to the exponent of a negative 2 over 3 to the exponent of a negative 2 like this, which is going to give us 8. So this will give you an 8 at the end. So this is how your questions might be given as. So be careful on your simplification, properly apply your laws until the final answer that you're given, you are working stage by stage, stage by stage. You factorize. The major part is for you to factor out what is common, provided that there is a common term. Do not force the terms to be common if they are not there. If there are no common terms, don't force them to be common. Just leave it like that. Move on to another stage. Just work with what is common. So I want you to try as much questions. Like I said, there are so many examples here. If there's a question that we still have a challenge on attempting on these questions that I did not attempt, let me know on the comment section so that we can work on those questions again in our next class.